practice Cinto. I'm working as a data platform engineer. I've been using Druid for a few years now, trying to cater to users like low latency analytical requests, and so far there's a lot of happy customers. So.
Hi everyone, I'm George. I work on the Polaris data engineering team at Imply, trying to manage all of our customers' clusters and auto-scaling and responding to any issues with the clusters.
Hi, I'm Ben Hopp. I'm a solution architecture lead on the field team of Imply. So I've worked with clusters of all shapes and sizes over many years. Great to be here.
Fantastic stuff. So, first question for Cinto. What do you think is the best practice for alerting on the health of a Druid cluster?
Druid has a lot of metrics, so we have to be a bit careful on alerting like on all of them, or else we'll get a lot of alerts. So one of the best practices I've seen is something like a smoke test that sort of ingests data into Druid, and then you query the data again and match them and see if things are working. That'll give you a good idea if the cluster is healthy at an overall level. You can then dig deeper into like individual clusters, like if you have queries that are slow or ingestion tasks that are not working, and then plan the metrics accordingly. But I think one of the best technique is having like a smoke test or something that can alert you on the overall health of the cluster.
And would you say that it's more important to look at sort of Druid-specific metrics that come out of the cluster, or to look more into kind of JVM-specific stuff, like the actual underlying processes?
It depends, again, what the issues are. You first look into, let's say, if it's a query issues, you figure out where the query is sort of lagging. Is it on the historical side, or is it on the broker side? And then you plan into wherever, if you see a lot of heap issues, you tackle it differently. So it will depend on what the actual issue is.
Cool. Thank you very much. Next question for George. More and more people are treating infrastructure as code. How do you handle this for Druid, and how does that fit into a containerization strategy?
Yeah, I think for handling infrastructure as code for Druid, generally trying to use like static templates and things like that is not going to work, because it's a pretty complicated system to deploy. You need to worry about things like volumes. There's an open source Druid operator at Imply. We have kind of built our own operator internally. I think that's kind of the best way to try to support an infrastructure as code strategy, where you deploy an operator and then you define your Druid infrastructure as a custom Kubernetes resource.
Are you doing that in Helm? Are you templating in that, or what are you using for your ISC?
So yeah, when you deploy an operator, you deploy the operator usually through Helm, and it exposes a custom resource. So an open source Druid operator is just like a Druid resource essentially, and then you deploy your custom resource the way you would deploy any other resource in Kubernetes.
So cool. Ben, do you have any thoughts that you'd like to add to that one?
No, I think he covered it pretty well. Yeah, I think that Druid, as it matures and being able to containerize services, really helps with the auto scaling. Right now, that's kind of limited to ingestion, but there's no reason that it has to always only be limited to ingestion. So I think that it's going to be how we manage the infrastructure, especially in Kubernetes environments, is really going to drive the overall architecture of the product.
Another question for Ben then. What are the most important metrics to collect on the Druid cluster?
Oh boy. All of them, I guess. Some metrics you're going to use for like alerting. Usually that's the top level metrics, like the query time or ingestion lag. But all of the metrics are valuable for troubleshooting issues. I think that one of the common issues that I do see is people over alerting, where they'll put alerts on things like, historical query time, or, individual metrics that are very useful for diagnosing issues, but really you just need to know, how is the query performing? Like, what's your average query time, P98 query time, ingestion? You just need to know how many events are there. Is there any lag? But then kind of drilling into that, when you want to actually troubleshoot query performance issues, you want to be able to see every step of the query execution, what the performance looks like. So, I think that the Druid metrics mechanism is crucial to having a well-running Druid cluster. You're not able to just glean that information from this host system. You have to actually get it from the Druid JVMs.
Super interesting. Thank you.
Yeah, I think it's important. Like, people have probably seen the Druid metrics documentation. There's like hundreds of metrics on there. It can be kind of intimidating. I think it's important not to like start from there and try to like alert on every metric there. It's best to start with like, what are you trying to do? Usually that's monitoring ingestion, or like in the last talk, Ben mentioned, how sometimes querying can be a little bit more forgiving, but usually you're going to want to measure querying as well. And then you kind of start from what you're trying to accomplish. And then if ingestion, the first thing you normally would measure is lag. And, then you would sort of go from there. Like, if lag is increasing, you would want to look at the health of the overlord. There are metrics that you should look at for that. And I think something like Kubernetes is pretty helpful for running Druid as well, because Druid is kind of, one core concept of Druid is it takes advantage of like cheap memory in modern systems, and it uses a lot of memory. So Kubernetes is a good system for like, setting memory limits, things like that, telling when you're going over memory thresholds.
One good thing that worked for us is having like 3 or 4 alerts, and then the rest may be like dashboard. So you look at trends. If an alert fires, then you look at trends and see if something has gone wrong, things like that. So.
Interesting. Thank you, guys. One question for the whole panel. I'd be really interested to hear your thoughts on this. What's the worst thing you can do or fail to do on a Druid cluster?
I guess I will start. And I think the thing that I see people try to do and fail most frequently is just a lift and shift from another system. Druid is a specialized tool or semi-specialized tool, and modeling your data for Druid, modeling your queries for Druid, I think are what really lead to successful deployments. If you're coming from a Microsoft Analytics services and you have 3,000 line stored procedures that you're trying to put into Druid, that is probably not going to work very well. So, actually building the system the way that Druid wants it to be built, for lack of a better way to say that.
One basic thing I would say, I think everyone knows it, but it's things like compaction. Although there would be property to say, okay, the sizes of each, let's say, segments should be 700 MB or something, but people don't realize the data doesn't work accordingly, right? You could have smaller segments. It's always a good idea to keep compacting the data so that you meet your sizes and things like that.
I also think one of the worst things you can do maybe is to do nothing. Druid clusters, there's like a lot of configs, as was talked about in the last talk, and there's things you need to do like resizing. Obviously, Will would like us to update Druid clusters more frequently, software versions. So I think it's important to not be scared of updating your Druid cluster. It's important to build a system that lets you upgrade frequently. That's just kind of where it is at as a system.
Yeah, I guess one thing I'll add is people often try to do too much with Druid. They will spend huge amounts of time trying to find configurations that are going to maximize their hardware resources, and oftentimes there's kind of very little return on investment. Unless you're trying to address a specific problem. Usually the default settings are there for a reason. And trying to go through and customize every setting to maximize your performance will, at best give you a little gain, but at worst lead to instability of the cluster or more problems down the road. So, you definitely, all those knobs that you can turn are there for a reason, but don't start turning them unless you have a clear goal that you're trying to achieve.
Great stuff. Thanks, guys. Another question for the three of you. What are the signals to look for to determine when a cluster should be scaled up? And how can I determine if I can safely reduce the size of my cluster without hurting performance?
I guess I'll take this one also, since it's kind of ties into both things I just talked about. I think when you are getting to a point that you feel like you may need to size up the cluster, the first thing is to find out where the bottlenecks are in the cluster, and this is where the metrics are very important. Sometimes scaling up one area is not going to do anything for your performance. So if you look at the metrics and determine that your historical processes are the bottleneck to query performance, that's where you want to start scaling up. There isn't a clear line that says the cluster's too big or too small. It really comes down to your SLAs, and if you want faster queries, scale up. If you can tolerate them running a little bit longer, maybe you don't need as much hardware as you're currently running, but Druid is really good about using all of the resources it has available. So finding that point of diminishing returns is critical, and that's why the metrics are there.
Yeah, if you look at your, even for scaling down, if you look at your CPU, maybe the max CPU usage and memory, and if it's been consistently low, that maybe it's a sign that you can maybe scale down a bit. But again, you have to test it out and see if that doesn't have any adverse effects and stuff.
Yeah, I agree with Ben. Basically, you need to look at the components that you need to scale, right? The most obvious one is if you're out of disk space, then that one you can just probably scale up. But for query, you need to look at segment wait time, segment query time, and see are these queries timing out? Do we need to scale out? For ingestion, you need to look at your lag and see if it's acceptable. See if your ingestion jobs are completing quickly enough. And scaling down is really the same thing, right? Just in reverse.
Great stuff. Moving on now to some questions from the audience. Thank you to everyone who submitted those. Again, feel free to jump in and answer when you feel like you have something to say. First audience question: what specific metadata backup/restore practices have you seen in the wild, and which ones would you endorse?
Easy answer is back up your metadata database very often. It used to be possible to rebuild a metadata database from the segment files, but that is no longer possible, and it's not going to be possible in the future. So make sure your database is backing up frequently. If you do happen to need to restore, luckily Druid is forgiving in that whatever segment files were created after the metadata store are not going to impact future operations. So you might lose the most recent data, but when you add data back in, it's not going to get conflicts or anything like that. But yeah, the easiest solution is use something like RDS and put on the automatic backups and don't think about it anymore. Well, think about it a little. Make sure those backups are running.
One piece of advice I've often heard when I was working DevOps was to go and test your recovery methods periodically to see if they're working. Is there a good way of doing that with Druid in terms of going and recreating your metadata and things like that to make sure that your DR process for metadata is working? Or is it something that is best left alone until you really need to change it?
I'm generally spoiled that I'm working with Imply and not open source Druid, so that's abstracted away for the most part. But yes, obviously recovering your metadata and testing out what the recovery procedure will look like is important. It's also especially important when you have streaming data coming in. You need to understand like what your recovery time objectives are, and making sure that your Kafka retention period is enough that if you do have to restore from a backup and re-ingest data, that it hasn't fallen off the Kafka topic.
Yeah, I think Druid is pretty easy to restore test as someone who has done it before accidentally and on purpose. It's built to be restorable. You just take your backup in the metadata store and you point it at your deep storage and, you let it go. And you run into issues like Ben said, your Kafka retention, things like that. But those are things you'll discover from the testing.
Great stuff. Thanks, guys. Another question from the audience. How do you evaluate new versions of Druid before you deploy them?
I think I can take this one. The best way is to have like a dedicated cluster that you can easily go on the newer versions. There could be bugs and everything on the newer ones. It's best to have a dedicated cluster, run some perf test, benchmarking, look at all the use cases. There could be some difference in query patterns as well. So look at those and see if everything sort of makes sense, and then only release it with a sort of wider audience. So that's one thing that will surely help.
Don't let your cluster fall too far behind. Almost all of the problems that people have with upgrades occur when they are upgrading from a version that's over a year old to the most recent version. The software generally has backwards compatibility, but for some features, they will actually remove the code. So if you're going too many jumps in the software, you could end up with problems. But regardless, having a staging environment that you can test the upgrades is very important. Also, test different features. Although there may be a new feature introduced, it may be turned off by default for backwards compatibility, and you may want to turn that feature on. So you also want to be able to test your configuration changes in a non-prod environment.
Great stuff. Another question from the audience. What resource utilization level do you shoot for in production under average/peak load conditions? This one's close to my heart, having been woken up in the small hours of the morning by databases that were using 80% of their memory, which, not necessarily a get out of bed kind of emergency.
Yeah, it very much depends on the use case that you have. Druid, like I mentioned before, it's very good at using the available hardware. So a single query can cause all of your historicals to spike up to, almost 100% usage. And that's not a bad thing, because that means you're using all your hardware. But it does make kind of sizing a little difficult because it's a very spiky workload. I often have people kind of complaining that they're underutilizing their hardware because they see that the average CPU is under 10%. And in the Druid world, that's not bad, because if you restrict it down and have your hardware, averaging 50%, your query performance is definitely going to suffer because there's not enough capacity to handle those bursts of queries. Yeah, it depends. I also have customers that have very predictable workloads, and they will run their hardware much higher average loads, but generally anything over 80% average is definitely going to be problematic. But most of the clusters I work with average under 10% CPU utilization.
Yeah, one thing to note is the utilization, like CPU, is very spiky. So in some cases, what I've seen is the metrics are emitted from these underlying nodes. They're at a higher granularity. So what happens is you don't see those spikes, and it looks like that your cluster is underutilized, but because we miss out the spikes sometimes, so that's something we need to take care of, whether the metrics actually is correct or not. So yeah, that's something we have seen.
Great stuff. Thanks, guys. Another question. How safe is it to perform rolling updates? And this is asking, alternatively, we've just seen a talk from Netflix on a cluster level blue-green deployment. So I guess they're asking about the merits of rolling versus blue-green.
I think rolling updates are generally very safe. Again, the problems lie when you're going between large version jumps, going from Druid 30 to 31. Very rarely will people experience any sort of issue, but if you're coming from Druid 12 and going to 31, then you can have problems because there's been so many changes in the meantime. So having backwards compatibility for something that's 5 years old is probably not going to happen.
Rolling updates are, I think, not only safe, but at least I recommend them because your clusters don't need a downtime. There are a lot of configurations in Druid, in Kubernetes that allows you to have a graceful sort of shutdown. So it ensures that your queries don't fail, your ingestion tasks have minimum impact. So I think I totally agree that rolling updates are totally safe. As long as it's between, I think, as you mentioned, between the window of upgrades, you don't upgrade from, let's say, a 24 to 30 or something. If you don't do, it should be totally fine.
And there's a question from the audience. When a node in the cluster is brought down, all queries or ingestion jobs in them will get killed. Is there a graceful way of recycling or restarting these nodes?
I can talk about ingestion specifically. There are several systems now in Druid that handle some form of auto-scaling ingestion, not necessarily vertical auto-scaling, but sort of more auto-scaling in the sense of an AWS auto-scaling group where you're trying to maintain a certain set of nodes. If you're running something like Kubernetes, you are going to want to have a pre-stop hook, or you might have this operation defined in your operator, but you'd want to wait for all jobs to finish on a pod. And that's something where the auto-scaling can help because if you're going sort of one by one, it's going to take a long time to, wait for all the tasks on one pod to finish and then sort of moving on to the next one. But if you can do something like spin up a bunch of new middle managers or ingest pods at once and then sort of schedule all the current ones for teardown and let them finish their tasks, that's a good thing to do.
And when we're talking about the historical services, there is a configuration called decommissioning nodes. Prior to shutting down a node, if you add it to the decommissioning list, it will kind of signal to the coordinator to move the segments off of that node. If you are running a small number of replicas, possibly even one replica, shutting down a node directly could cause some data to not be available. So if you decommission it first, it will ensure that the data stays available no matter what.
Now, even from the querying standpoint, you can add, as you mentioned, pre-stop hooks and to ensure that these brokers, they have a graceful shutdown. So it can only shut down when, let's say, all the queries are executed and the new ones will go to the new broker. So there's things in place that can ensure graceful shutdown.
Great stuff. Another question from the audience. If you could choose to fill one feature gap for Druid operators, what would it be? That's a tough one.
I think there are a lot of things that run in the task system now in Druid, and there are more things added somewhat frequently. Like there are MSQ queries, async queries, auto compaction. It can be kind of hard to run sort of these kind of diverse workloads on a single set of ingest nodes, middle managers. So I think sort of worker categories and having tiers of middle managers is pretty important. So I would like to see sort of better support for launching multiple tiers of middle managers of ingest and targeting tasks at these sort of pools.
It's really interesting. Yeah, I know. I've had a lot of fun in the past with scaling middle managers around ingestion jobs. The next question from the audience: how do you educate users to use Druid for the right use cases and not to treat Druid as a regular data warehouse, which sometimes turns costly for maintenance?
I think it's tricky because if you ask a user, do you need sub-second, most of them will say yes. Although they may not need it, but it's like, so it's tough to educate, but usually how we treat it is if it's serving like an application workload, or you need really real-time streaming and you need data freshness within, let's say, a few seconds. Those are good pointers to say that, okay, maybe Druid is a good fit. If the query patterns are sort of identified that okay, these are the type of queries you want to run, maybe that's also a good use case rather than saying, okay, I don't know what are the type of queries, then it may slowly move into the sort of the data warehouse field.
Yeah, I guess for me, since I'm working at a software company, the educating users really comes as how do you talk to potential customers to see if their use case fits with Druid. And I find that pretty easy to do because I'm also on the post-sale side. So I just, think to myself, is this something that I want to support after it's been sold? And, when somebody comes in with a use case that is not a good fit for Druid or would be a better fit for a different technology, I usually just tell them that, I guess. I don't have, internal stakeholders that I'm necessarily educating, but part of the sales cycle is to educate the people that are interested in Imply or Druid, and making sure that what they want to do is something that they can actually succeed with Druid.
Great stuff. Another question from the audience. What is your stance on NVMe local store versus network block storage? And presumably that's for deep storage in a Druid cluster.
Yeah, nothing beats NVMe, I will say that. However, the gap between direct attached storage and object storage or block storage has shrunk dramatically. So I believe, Polaris now is using all network block storage, and the difference between that and direct attached storage is just a couple of percent. So I think that some use cases, especially ones that are very heavy with random seeks, will see benefit from NVMe, but doing the testing yourself and seeing if it's worth the cost is really important.
Great.
I think I'm on the same page. I think EBS is a pretty good default. It also lets you do some interesting things during updates if you want to try to reattach disks rather than pulling down segment files. I would say, like for AWS specifically, I think a pretty reasonable heuristic is if you're starting to think about changing the defaults for your EBS volumes, that's when I would consider NVMEs instead, because it can be quite expensive actually to increase IOPS and throughput on EBS volumes.
In a previous life, I worked as a storage engineer at IBM, and I would say on this one, particularly with cloud providers like AWS, you might be talking about the difference between NVMe in that box or NVMe on the floor above connected over fiber. So you shouldn't be trading too much latency, although certainly if it's in different regions, you're going to have a fun time. But yeah, in a modern data center world, it's becoming much less of a concern, although definitely there's still room for optimization there. Next question from the audience. Since Druid has an abundance of configurations, where do you recommend starting to tune Druid to be more performant?
Start with the problem that you're having or that you want to address. I think that although it's kind of expansive, going to the Druid docs and using the recommended configs and just running with the recommended configs for a while in production to see how it performs. And then if there are problems that arise or areas that need to be addressed, you can kind of start tuning those areas. But you shouldn't just go in blind without a baseline test on that. So, keeping those metrics so that you can easily compare and do the analyze performance before the change versus after the change. So make sure you are tuning to a specific goal and not just fiddling with things, trying to make a nebulous concept better.
Yeah, I think I have had a very good experience with the recommended configs, things like your segment size, the merge buffers and stuff like that. You start with that, see if it's is doing good, and then it's easy to scale up. Druid does very good in like scaling up and down, so you can always have those settings and then scale up your individual services to see if that works. Usually that's pretty good place to start with.
So another disaster recovery question. Have you seen any mature processes for manual recovery from failed ingestion conditions? For example, using spot instances for catch-up indexing.
I think that the auto-scaling of middle managers has largely made that moot. Whether you're using spot instances or K8s pods or however, it allows you to dynamically scale the ingestion to, handle a backlog of data. I don't know that spot instances alone the savings of a spot instance over a reserved instance would be that much for an auto scaling type of use case. But also keep in mind that your ingestion can only scale to as many partitions that you have. So that could end up being your limiting factor, not the actual ingestion tasks.
A follow-up question here to our earlier question around cluster utilization. You mentioned spikes in utilization from expensive queries are not necessarily a bad thing, as it means the cluster is being fully utilized. What strategies do you recommend to avoid longer-running, expensive queries from blocking or negatively affecting other queries?
I think, Druid has things like tiering and laning. And so if you know which are your, let's say, good queries from bad queries, you can always lane it correctly so that you have an allocated set of resources for, let's say, the expensive queries. Or, maybe the users are playing with Druid, so those go to the other lane, and you have a P0, let's say, lane that has dashboard queries which are more critical. So Druid has inbuilt features for this, so it should work.
Yeah, I think that there's a lot of different strategies that can be used to isolate resources, but managing your query timeout is kind of the unsung hero of those configurations. Since we can't physically restrict how many cores a query uses, we can only really control the concurrency. Having a timeout that is realistic helps. And when I say realistic, having too short of a timeout will just cause a user to resubmit the same query a bunch of times and continually just kind of slamming the cluster. But having one that's too long, if the user browses away from the page that's running that query, chances are good that it's going to still remain running. It's not going to kill the query. So you want to be protective of your cluster resources, but kind of keep in mind that users are more or less predictable in that if something isn't coming back in single-digit seconds, they're either going to refresh the page and issue a new query or give up on it. The other thing I'll say is try to keep your workloads consistent, or at least don't mix kind of the ad hoc, very spiky workloads with like a consistent workload of API traffic. If the data, is small enough and you can actually run 2 separate clusters, that's the best way to isolate resources. So you don't have to worry about laning and tiering. You just segregate everything based on which cluster it's going to.
Great stuff. Another question from the audience. For segment-related performance problems, in your opinion, what common pitfalls should be avoided when doing some troubleshooting?
As was mentioned before, we kind of have a general guideline of 300 to 700 megabyte segment sizes. Compaction is a great way to keep those segment sizes in that range. I think whenever possible, limiting your late arriving data is the best way to keep those segment sizes appropriately sized and reduce the amount of compaction that's actually necessary. Having a long tail of late arriving data pretty much guarantees that compaction is going to be constantly running, constantly using more resources on your cluster. So if the data is no longer valuable, if an event has a timestamp from 1998, often it's safe to throw that away rather than having Druid create a segment for it.
Great stuff. One thing I would always suggest as well is keep a very close eye on your ingestion granularity, because I've seen examples where people have been ingesting with very small segments and they have a lot of data coming in very quickly and they end up with thousands and thousands of segments in a day, and that will absolutely eat your performance. So yeah, always think about your data modeling and your granularity for ingestion. We have some really good documentation on that in the courses on learn.imply.io around data modeling and Druid. So do check it out if you're having trouble with that. Another question from the audience. How often do you suggest to your user to apply custom resource settings in the query context object of the request?
I usually suggest it right before making a change. Setting the properties in the query context allows you to test configurations without applying it at the cluster level. In most cases, having per query configurations is overkill, but if you're trying to address a specific issue, if you're getting the max subquery rows exceeded and you want to test what if you can set it higher without having performance issues, doing so in the query context is very valid. But eventually I would recommend moving those configurations after they're thoroughly tested into the runtime configuration so you don't have to set it with every query. But things like priority and timeout, setting those in the context can really be helpful because those are things that each query could be treated differently. If you have a long-running query, you might want to set the priority very low and have a high timeout versus your interactive queries, which lower timeout, higher priority.
Great answer. Another question from the audience. Real-time ingestion has to create a new segment where data falls into a new segment granularity. How can we protect against a rush to create segment calls at the top of the hour?
I assume this is assuming that there's an hour task duration, and then there's intermediate handoff configurations. I think just going with the defaults is usually a good place to start, and that kind of lets the Druid handoff sort of feature during streaming can be a thorn sometimes because like the question says, you get a bunch of segment calls that are lined up. You end up with a bunch of tasks being launched at the same time as well. Intermediate handoff is kind of built to try and address that. There are also some features that have been added to supervisors, stop task count, early handoff of tasks that are potentially also worth looking into to sort of add some jitter into the task handoff times.
Yeah, I generally only see kind of the rush of new segments being a problem on clusters that are running a very high number of tasks. If you run 200 tasks, it's going to open 200 new segments, at the hour. I don't think that that's something that's unmanageable. Usually we don't have to do any specific configurations to handle that kind of volume, but things like the stop task count, where instead of having all 200 tasks shut down at the same time and spin up 200 new ones, roll over the tasks in groups, can really not only help the performance in that aspect, but also have minimized the flood of traffic to the metadata database when tasks are rolling over.
Super interesting. One final question from the audience before we wrap up our session with these awesome panelists today. When auto-scaling ingestion, how do you ensure a balanced load across indexing tasks, since Kafka partitions may not divide equally among those tasks?
Well, if your Kafka partitions are not balanced, there's no way to balance the indexing tasks. So make sure your Kafka partitions is balanced is the easiest way. The other have note is the larger the middle manager is, the more it kind of has a natural load balancing effect. So if you have one middle manager with 10 task slots, you have a smaller risk than if you have 10 small middle managers with one task slot each, because in that case, if one of those tasks is very heavy, it can cause overall slowness. Whereas if you have 10 slots, you might have some that are heavier than others, but it all kind of balances out.
Great stuff. Thank you for that. Well, we had some really deep dive technical stuff in those questions from the audience there. So can we have a huge hand for our panelists for their great job at answering that?